Welcome to Blue Health Daily.
An ancient shadow awakens in the silent darkness of a microscopic world. For millions of years, single-celled entities ruled the Earth with absolute dominance. Bacteria enjoyed their long, uninterrupted golden age before humans even existed. They were the invisible masters of life and death, shaping the primordial world. The plagues of the past wiped out entire empires without leaving a single trace. Black Death, cholera, and tuberculosis created terrifying waves of destruction through history. Millions of human lives vanished into thin air because of these microscopic killers. But humans did not even need a famous deadly disease to face sudden death. A tiny, ordinary scratch on a finger during daily work could easily kill a king. Inside that small skin tear, the invisible invaders began to feast and multiply rapidly. The human immune system would immediately wake up and rush to the battlefield. White blood cells fought bravely, trying to devour every single invading alien cell. But if they encountered a highly aggressive strain like Staphylococcus aureus, things changed completely. The human body simply could not produce enough soldiers to match their exponential growth. The invading army doubled their numbers every 20 minutes without ever slowing down. Without any external support, the overwhelmed immune system eventually suffered a crushing defeat. Ancient medicine desperately tried to fight back, using various natural herbal remedies. Healers applied moldy bread, fermented mud, and strange plant extracts onto open wounds. None of these primitive methods could truly stop the aggressive biological wildfire inside. Throughout the long march of history, infection remained the absolute #1 killer. The average human life expectancy in those dark times barely reached 40 years. Even at the dawn of the 20th century, the world was becoming highly sophisticated. Yet a tiny prick from a rose thorn still held the power to end any life. Science finally discovered that these terrible infections were caused by living bacteria. However, finding a safe and effective medical treatment remained an unsolved mystery. Destroying the bacteria without killing the human patient was the real challenge. The great turning point arrived unexpectedly from a messy, forgotten laboratory bench. Penicillin, the very first true antibiotic weapon, was successfully mass-produced in 1942. It was derived from a humble strain of mold that naturally produced a deadly defense. This miraculous substance specifically targets and eats away the cell walls of bacteria. As the protective wall grows thinner, the immense internal pressure becomes completely unstable. The bacterium suddenly bursts open like an overinflated water balloon in a flash. This revolutionary method did not kill every single type of harmful bacteria on Earth, but it successfully wiped out a massive group of the most common human killers. Penicillin rapidly saved millions of soldiers and civilians on the battlefields of World War II. It was widely celebrated across the globe as a true miracle of the modern era. Realizing the incredible power of microscopic fungi, researchers unlocked a new frontier. Scientists began traveling to every corner of the world just to scoop up handfuls of dirt. They frantically searched for wild soil microorganisms that acted as natural enemies to pathogens. The magnificent golden age of antibiotic discovery had officially begun for mankind. Dozens of powerful new antibiotic families like tetracycline and amoxicillin were born. These life-saving pills quickly filled the shelves of every local pharmacy worldwide. From that historic moment on, human life expectancy experienced a dramatic, steady rise. The average lifespan of human beings nearly doubled compared to the pre-antibiotic era.
But deep down, science knew that antibiotics were never a permanently perfect weapon. Each specific type of drug possesses its own unique method to execute the target bacteria. Some puncture the outer membrane, some inject chemical poison, others steal vital proteins. After completing their deadly mission, these tiny assassins are naturally flushed out by the body. When using these weapons, a strict fundamental rule must be followed without any exception. You must pull the weeds out by their very roots to prevent any future trouble. The very last pill in the prescribed course must destroy the absolute last surviving bacterium. If you fail to do this, the remaining bacteria will inevitably learn to resist the drug. This dangerous adaptability is actually deeply rooted in their ancient primitive nature. Ancient infections thousands of years ago also contained plenty of drug-resistant individuals. But a strange paradox occurred when humans did not have the means to kill them. In the ancient world, these unique mutant bacteria usually died out on their own. Yet in the modern world, when we use drugs to wipe them out, they survive. The secret lies in the way bacteria reproduce through simple, rapid binary fission. They endlessly clone their own bodies, but the duplication process is never completely perfect.
Occasional copying errors occur, causing the new generation to possess a genetic mutation. The bacteria themselves have no control over how these random mutations alter their bodies. It is an entirely accidental event driven by the chaotic laws of nature. A newborn cell might possess a strange protein or a slightly altered internal structure. Many mutations are highly detrimental, causing the cell to die instantly after birth. On average, only 1 in a million newborn bacteria carries a beneficial survival mutation. This seems like an incredibly low probability that humans should not worry about. But the real problem is that bacteria multiply at a mind-blowing, terrifying speed. A single population can double its entire numbers every 20 minutes without a break. A mere 1,000 bacteria can explode into a massive empire of 1 billion in 7 hours. Because of this sheer volume, they never run out of helpful genetic mutations. Let us examine an imaginary example of person A, an ancient human with a sore throat. The bacterial colony inside person A contains a few dozen random mutant individuals. But no matter how unique their mutations are, it gives them no special advantage. In the ancient world, every single bacterial cell was forced to live in absolute equality. They all faced 2 massive, overwhelming threats to their daily survival. First, the host immune system was constantly hunting them down without mercy. Second, their own massive numbers meant intense competition for a limited food supply. The mutant bacteria had absolutely no special room or extra resources to expand. Their ultimate fate was exactly the same as their ordinary non-mutant relatives. They were either completely wiped out by white blood cells or died with the host. Even if they managed to jump to a new human host, the cycle just repeated. Now, let us step into the modern world and look at person B with a sore throat. Person B walks into a pharmacy and purchases a standard 5-day course of antibiotics. This particular drug kills the invaders by aggressively puncturing their outer cellular shells. 10 million bacteria are currently thriving and causing pain inside person B's throat. Among this vast population, a few rare individuals happen to possess a unique mutation. This specific mutation accidentally grants them a significantly thicker outer cell wall. This physical trait instantly creates a major obstacle for the incoming antibiotic molecules. On the very first day, person B swallows the first prescribed dose of medicine. The drug works alongside the immune system to wipe out 30% of the invaders. The thick-walled mutants shake off the light damage and continue to divide. On the second day, the total number of competing bacteria drops significantly lower. The antibiotic molecules easily destroy half of the remaining ordinary population in a few hours. The antibiotic molecules finally begin to surround the unique thick-walled mutants. However, a single chemical strike is simply not enough to break through their thick armor. The resilient mutants manage to survive the day and continue replicating their genes. By the third and fourth days, the drug's numerical superiority increases drastically. The ordinary bacteria and other useless mutants are completely erased from the throat. The thick-walled survivors are now isolated and heavily bombarded by the medication. They are punctured multiple times and begin to die off in large numbers. By the end of the fourth day, almost the entire bacterial empire is totally ruined. Only a tiny, weak handful of the toughest thick-walled mutants are barely hanging on. Their final demise is completely guaranteed because the fifth-day doses are coming. But Person B suddenly looks in the mirror and makes a critical, uneducated decision. Because almost all the bacteria are gone, the painful symptoms have completely vanished. Believing that the body is fully cured, Person B puts the remaining pills away. This single, seemingly innocent act changes the course of biological history forever. Suddenly, inside the dark throat of Person B, an incredible shift occurs. Every single competing bacterial strain that fought them for food has been eliminated. The host immune system is not fast enough to catch the few remaining survivors. Finding food and space becomes easier than it has ever been in their existence. The thick-walled mutants are left completely free to multiply in a total biological vacuum. Within hours, they rebuild a massive empire of millions of identical thick-walled cells. All the antibiotics Person B consumed turned out to be an excellent clearing service. The antibiotics inadvertently wiped out their enemies and paved the way for their rise. Now, Person B falls sick again with a much more aggressive, persistent sore throat. Person B sneezes and spreads this newly perfected strain to several close friends. The victims are now infected with an entirely drug-resistant generation of pathogens.
Inside these new hosts, even stronger mutations will eventually occur over time. They will patiently wait for the next human to stop taking their antibiotics early. If the danger was limited to this single mechanism, it might still be manageable. Even if humans help select ultra-thick-walled cells, science could theoretically adapt. Doctors could simply prescribe a much higher dose or switch to a stronger drug. Unfortunately, bacteria possess another terrifying biological trick up their microscopic sleeves. They do not simply pass their survival genes down to their direct biological offspring. They can actually transfer these resistance genes directly to completely different bacterial species. This process is incredibly simple, fast, and highly efficient in the microscopic world. They literally copy their elite survival DNA and hand it over like a physical gift. Suddenly, it is no longer just one specific type of bacteria that possesses the armor. Multiple, entirely different families of dangerous germs gain the exact same resistance overnight. Each distinct population continues its own independent loop of infection and survival. They constantly use human carelessness to test and refine their genetic defenses. They trade their unique resistance traits back and forth in a never-ending cycle. Deep inside an unmonitored human body, a true biological monster slowly takes shape. A multi-drug-resistant superbug is born, completely immune to our entire medical arsenal. Now, absolutely anyone can become the next random host for this unstoppable killer. The rise of superbugs begins with a random copying mistake by a single cell, but it is ultimately finalized by the widespread ignorance and carelessness of humanity. These terrifying medical scenarios have been playing out since antibiotics first appeared. Penicillin was widely distributed to the public for the first time in 1942. Just 2 short years later, penicillin-resistant strains were already spreading through hospitals. Tetracycline was proudly introduced to the medical world in the year 1950. 9 years later, bacteria successfully developed a complete resistance to its chemical formula. Daptomycin was deployed as a powerful defense weapon much later in 2003. Tragically, it took bacteria only 1 single year to render it completely useless. Right now, countless individuals lose their lives every year to these incurable superbugs. Modern medicine is forced to stand by helplessly as patients succumb to basic infections. This global casualty number is growing significantly worse with each passing day. We are pushing our scientific laboratories to create brand new antibiotic options, but this has turned into a completely unfair losing race against evolutionary biology. Human scientists must spend thousands of hours of intense intellectual labor for one drug. Meanwhile, a bacterium needs only 20 minutes to complete a generation and mutate. The harsh reality is that the discovery of truly new antibiotics completely stopped. Since the late 1970s, no entirely new chemical class of antibiotics has been found. We have already dug up and analyzed almost all the natural soil on Earth. Most modern new antibiotics are actually just slightly modified versions of old ones. On the medical front lines, doctors are forced to prescribe maximum strength doses. They aggressively combine multiple heavy antibiotics together to ensure total destruction. These massive chemical bombs inevitably wipe out millions of highly beneficial gut bacteria. In the worst cases, these extreme chemical doses can permanently damage vital organs. While scientists struggle with human cases, a massive new front has opened. The global agricultural industry has become a primary driver of drug resistance. Disease is the absolute greatest financial nightmare for large industrial farmers. They raise thousands of animals in incredibly tight, highly stressful environments. Farmers routinely mix low doses of antibiotics directly into daily animal feed. This widespread practice gently clears away weak bacteria, leaving a perfect arena for superbugs. These agricultural superbugs expand rapidly across massive livestock populations without any resistance. Furthermore, antibiotic residues remain trapped inside the meat products we purchase. These chemicals also leak directly into the surrounding soil and natural water systems. The final long-term impact of this environmental pollution on human health is terrifying. On every single measurable front, the microscopic enemy is gaining ground. What can the human race possibly do to prevent this apocalyptic medical future? Medical authorities strongly advise letting the human immune system fight light infections. We should only resort to antibiotics when facing an exceptionally dangerous pathogen. Another critical fact to keep in mind is that antibiotics are not just found in medicine. Antibacterial soaps and floor cleaners all contain exceptionally harsh chemical substances. For waterless hand sanitizers, always prioritize choosing alcohol-based formulations. Regular soap does not kill bacteria, it simply surrounds and washes them all away physically. Until a future era of nanorobots arrives, regular soap remains humanity's most permanent weapon.
Knowledge is infinite, and what I know is, honestly, just a grain of sand in the desert. Hitting the like button and subscribing is totally free, but it's a huge motivation for me to keep making better videos for you. Thank you so much for your support. I hope this gave you some helpful insights into health. If you have any thoughts, questions, or comments, feel free to drop them below.